Good morning to all of you. So today we will be having the class of object-oriented database system. And in our last class, we have discussed about how to creating a table, how to creating a table, and all those things we have discussed in our last classes. But today we are going to discuss the continuation part of this table and the constant, what are the things, all of those things. That means the database designs and the consistency requirement for the subtables and all of those things, creating a table and under this that particular subtable, what is the requirement, what is the consistency requirement are there. So this is need to know. But before going on to that, before that, what are the constant needed for a subtable? All of these things we need to know that what is the correspond. So what is the particular correspond? So we can say that what is the correspond that the tuples in a subtable and a parent table are correspond. We can say that a tuple in a subtable and the parent table are correspond if they have the same values for all inherited attributes. If they have the same values for all inherited attributes. Thus, corresponding tuples representing the same entity. So, what can we say? What is a correspond? So, a correspond, we can say that it is a subtable in a subtable and a parent table. So, there are two tables. That is a parent table, and under that a subtable is present. So, we can say that a table or tuples in a subtable and the parent table is correspond or whether are correspond, we can say that if they have the same values for all the inherited attributes, if they have the same values for all the inherited attributes. So thus corresponding tables represents the same entity. So these consistency requirements for the subtables are, so what are the consistency requirements for the subtables are? There are two types of consistency. First one, each tuple of the supertable can correspond to at most one tuple in each of its immediate subtables. So each tuple of the supertable, so supertable means the parent table we can say. So each tuple of the supertable can correspond to at most one tuple in each of its immediate subtable. And second one is SQL has an additional constants constant that all the tuples corresponding to each other must be derived from one tuple. So two constants are there. We can see first one, each tuple of the super table. Each tuple, so every tuple of a parent table can correspond to at most one tuple in each of its immediate subtable. So a parent table and a subtable is present there. So each tuple of the parent table can be corresponded to at most one tuple, only one tuple in each of its intermediate subtable. And second one is SQL has an additional constant that all the tuples corresponding to each other must be derived from one tuple. Must be derived from one tuple. So additional constant are there that the tuples corresponding to each other. So whatever the tuples are corresponding to each other must be derived from one tuple inserted into one table, inserted into one particular table. So without the first condition, so whatever the first condition is present that in a particular parent table and the sub table, each of the constant that at most one tuples can be corresponding to each other. So students and we can say that the two tuples, students and the correspondent to the same person or teacher. So SQL does not support this type of multiple inheritance. So SQL does not support the multiple inheritance. So the second condition actually prevents a person from going both a teacher and a student, from being both a teacher and a student. So SQL does not support multiple inheritance. And so that's why the second condition, what is the second condition there? That is that SQL additional content corresponding to each other must be derived from one tuple. So it value or the tuple value must be derived from one particular tuple. But a person cannot be a student and a teacher. So maybe a person can be in real life that a person may be a student and also a teacher, but since SQL does not suppose this type of multiple inheritance, so the conditions actually prevents a person from being both a teacher and a student. Okay, so it would be very much useful to model a situation where a person can be a teacher and a student at the same time. Because in general, a person can be a teacher and can be a student at the same time. But since SQL does not support this type of teachers actually, so there is a problem. So that's why we need to model a situation. We need to model a situation where where a person can be a teacher and a student even if a common subtable teaching assistant is not present, but what But how SQL do this particular thing? Suppose you have a table person with subtables teachers and students. So the parent table is named as a person, and there are two subtables, that is the teacher and the student. So this we can have a tuple in teachers and a tuple in students corresponding to the same tuple in people. So if we have table person with subtables teachers and students, we can then have a tuple in teachers and a tuple in students corresponding to the same tuple in people. So there is no need to have a type of teaching assistant that is a subtype of both student and teacher. So a person table is present here, and the subtable, there are two subtables are present, that is the teacher and the student. So we can have a tuple in teachers and a tuple in students corresponding to the same tuple in people. So a tuple can be present in teacher and also a tuple in student corresponding to the same tuple in people. So what was the tuples are present in people actually deriving from the value from the particular person table. The value can the tuple can be in teacher and the tuple can be in student also. So there is no need to type or any subtype of having a teaching assistant that can be the corresponding of both student and teacher, because a teaching assistant can be a student and teacher at the same time, but here we can actually deriving the value and putting the particular value from the person into a teacher and into a student at the same time. So means it is that the person can be a teacher and at the same time it can be a student. So that's why we no need to create another teaching assistant subtype table there. So this SQL support does not support multiple entities, as I said. So we need to model a situation as I previously said. So SQL subtables cannot be used to represent overlapping specialization from the EUR model. So as SQL does not support this multiple inheritance, and it cannot be done at the same time that a person can be a student and a teacher. So SQL subtables cannot be used to represent overlapping specializations from the ER model. So we cannot use this SQL ER model to overlap to show any type of overlapping specialization. So, but we can of course create a separate tables to represent the overlapping of specialization or generalization without using inheritance. So we can use this. We can use of course some separate tables to represent the overlapping specialization or generalization without using any type of inheritance. Here we can see that our table has been created with the name of some person. So we should create a table called person, student, and teacher. So there are three tables we can see: person, teacher, and student. With the student and teacher table containing the primary key attribute of person. So what is the attribute or primary key attribute in the person? That is the ID, and that same ID is present in the teacher and the student. So the teacher and the student is having the same primary key of the table person. So the attributes are present in the person, that is ID, name, street, and city. In the case of teacher, it is ID, salary, department, and in the case of student, it is ID, degree, and the department. But in both of the cases, we can see that ID is the common thing, and person ID is the main primary key attribute, which is also present in our teacher and a student. So we can see that a primary key attribute of person, other attributes specific to students and teacher respectively. Now we are going to talk about this array and added to SQL in 1919. So array features have been added into the dimension single dimensional array of ordered elements into the of the same type array actually. So multi-set, and we can see that now as this array is added to SQL into a single dimensional array of ordered elements in a